Hello everyone, welcome to O for Organic. In the previous video, we discussed about electromagnetic waves. If you're not familiar with the term, I encourage you to watch my video on electromagnetic waves. You'll find the link in description. And in this video, we will be discussing about some of the properties of electromagnetic waves. Sun is a constant source of a variety of electromagnetic waves, like ultraviolet rays, gamma rays, visible light, X-rays, etc. But how do you differentiate between all these? Let's suppose if you are provided with a particular electromagnetic radiation, how would you find out if it is an ultraviolet ray, a gamma ray, visible light or an X-ray? To understand this, let us consider an example. If you were to identify your friend from a group of people, how would you do it? You can identify him or her by her face or height or physique. Or if there is no light and you cannot use any of these features, you can identify her by her voice. So to identify your friend or any other human, we use all these features or characteristics or properties. Similarly, electromagnetic waves can be identified using their properties. Now there can be a lot of properties of electromagnetic waves, but three of them are very basic and important. And these three properties are wavelength, frequency and energy. Now let's try and understand each one of them in detail. To understand wavelength, we first need to understand a few other terms. This is central axis, which shows time and also the movement of wave with time. Let's say we have a wave here that is starting from central axis, this point. It goes up, reaches a maximum distance, comes back to central axis, goes back in the opposite direction, comes back to the central axis and repeats the same movement. So the wave travels a maximum distance upwards from the central axis and the same distance downward from the central axis. So this topmost point is called as the crest. And this bottommost point from central axis is called as the trough. Now wavelength simply means length of the wave. So we have a wave here which starts from this point A and ends at this point B. So the wavelength of the wave would be the distance between point A and B. Wavelength is represented by a Greek letter lambda. So the wavelength or lambda of this wave would be AB. But like this wave, not every wave starts from central axis. So in such a case, how do we measure the wavelength? So we have two other methods of measuring the wavelength, and they are, you can measure the distance between two crests, or you can measure the distance between two troughs, or you can simply measure the distance from starting point and ending point on the central axis. So if I label all these points A, B, C, D, E and F, and it is clearly evident that all the three methods are going to give you the same results. So lambda here can be measured as AB, or the distance between EF, or the distance CD. So wavelength simply means length of the wave, and therefore any unit of length can be used to measure wavelength. Since SI unit of length is meter, hence SI unit of wavelength would also be meter. But a lot of electromagnetic waves have very small wavelengths, and therefore other smaller units like angstrom and nanometer are also used. Now let's turn to frequency. Understanding frequency is a little tricky, so let us consider an example here. Suppose there is a competition in which you have to run from point A to point B. Now in this competition, a father and his kid participate. Who do you think is going to win the competition, the father or the kid? At first instance, you would think that definitely the father is going to win the competition, because father is taller and therefore he would take bigger steps and would cover the distance in a shorter time. But what if I say that the father and the kid, they both travel this distance, run this distance in the same time? Means they both come out winning. How would you explain that? So definitely the father is going to take bigger steps because he is taller, and the kid would take smaller steps. So let's say this distance AB is covered by father in 3 steps, shown in blue here, and the same distance is covered by kid in 6 steps, shown in green here. But generally, kids are more energetic than adults. So while we walk, kids run or jump. If you look closely here, you will notice that in similar time, when father took one step, the kid took two steps. Obviously, because he is quick, fast, energetic. Let's say this entire distance AB is covered in 1 minute. So the father walks with a speed of 3 steps per minute, whereas the kid walks or rather runs with a speed of 6 steps per minute. So the size of steps can be considered here as wavelengths, whereas this 6 and 3 are frequencies. So we see here that the child has smaller steps but a larger frequency, whereas father has bigger steps but a smaller frequency. The same goes for waves also. So the waves that have larger wavelengths will have smaller frequencies and vice versa. Now the question is, who will have the higher energy? Here the kid had higher energy as compared to his father, so the wave with shorter wavelength will have higher energy. Now let's consider this with the help of waves. So here we have two waves, wave 1 with a wavelength of lambda 1 and wave 2 with a wavelength of lambda 2. We can clearly see that lambda 1 is smaller than lambda 2. Now if I say that both the waves cover the distance from A to B in same time, this means that wave 1, which had a shorter wavelength, jumped more number of times as compared to wave 2. So wave 1 covered the distance from A to B using 4 waves, 4 wavelengths, that means 4 lambda were involved, whereas wave 2 covered the same distance in just 2 waves, means just by jumping 2 times. So only 2 lambdas were used. So wave 1 jumped twice as compared to wave 2. So if I say that wave 2 travels with the speed of 1 wave per second, in the same time 2 waves of wave 1 will pass. So wave 1 will be traveling at a speed of 2 waves per second. So frequency of wave 1 is twice as compared to wave 2. So frequency can be defined as the number of waves traveling in 1 second. And it is represented by the Greek letter nu, and its unit is hertz. So frequency of wave 1 is 2 Hz, that means 2 waves are traveling in 1 second, and that of wave 2 is 1 Hz. So we can say that frequency and wavelength are inversely proportional. If one increases, the other decreases. And what about energy? Just like the previous example of the father and kid's race, the kid had more energy, hence the wave with the shorter wavelength will have more energy. So we can say that frequency and energy are directly proportional to each other, whereas both are inversely proportional to wavelength. So here we see that all the 3 properties of electromagnetic waves are interlinked, they are connected to each other, and therefore electromagnetic waves can be identified using any of the 3 properties. So if we have wavelength or frequency or energy of electromagnetic waves, we can easily identify if it is a gamma ray or cosmic rays, or if it is an infrared ray. And all these waves are collectively called as the electromagnetic spectrum. If you enjoyed the video, please don't forget to like, share and subscribe.